on what we talked about in the homework, right? There is a pre-depth, there is a drive-in, right? So you have three equations. If you write those and then knowing how to use Irwin curve, which we discussed many times, you get the product of RS XJ. So if you know RS, you can get XJ, or if you know XJ, you can get RS, whichever way you want to go. Okay, this one was just tell me the total resistor of this, if I printed this. So a lot of you got all right, but some of you, I don't know why, you missed it, but we know the ends are 0.65 square. This is 0.65, right? And then corner is 0.56. So then all I need to know is what is the squares here and what is the number of square. So number of square here, you can see 65 is this length, right? Because 2.5 down in the corner, 2.5 here. So this is 65 divided by 2.5. So that's the number of square in this branch. Okay. And number of square in this branch is 15, because this is 15 divided by 2.6. So now you just add these things, 0.65 from here, then this number, then corner, then this leg, and then this. So you got 33.8 squares are there in this whole pattern. So now your resistance is nothing but the number of squares times the sheet resistance, which is given to you 678. So that is, a lot of you got this all right too. Some of you had trouble getting this number. I don't know why, because you can, if you draw this thing, you can see that this is 65 micron. So how many squares are there divided? So this was the question there. Final question was, what is the three main constituents? What are the three ingredients inside the photoresist, right? So we talked many times, we got a photoactive compound called PAC, okay, which absorbs the light, okay, and then transfers that energy to the polymer, okay, which is the second to initiate a chemical reaction. That's the way the PAC works. This is the absorber of the light. Then the second constituent is polymer, okay, which is an organic material, and this is where the reaction is happening. And there are two things can happen. The reaction can make the polymer hard if it cross-links, or it can make it weak if the cross-links are broken. So I said that in the case of positive resist, which is one of the questions, how it operates on positive resist. So I said in the case of positive resist, it makes it weak. The light makes it weak by breaking the cross-links, and therefore it dissolves. So this was this is basically constituents, and the role is what I'm asking. Okay, then the third is solvent. Solvent basically is there to control viscosity. I talked about the mechanical properties. You just put the two in the solvent. So it controls primarily the viscosity. So that's the question for this. So tell the constituents of the photoresist and the role of the, and use positive resist as an example. Okay, with this one, most of you got this, did well on this question. Majority of you did very well. So this was the simplest question that you were given Na and K1 and K2, right? So you calculate the resolution and depth of focus. So this formula is given to you. K1 is known, the wavelength is known, the Na is known. So the resolution is 0.365. Okay, next is the depth of focus of this machine. This is the formula given to you. All these numbers are known, 0.73. Then the question is, if this is the system you have, if I am trying to do lithography where my minimum feature size is 0.4 and the depth of focus required is 0.5, will this thing work? So answer is yes, because my resolution that you want, I am better than that. I want to print less than feature size of 0.4. I can print less than that if you like. this passes this test. Depth of focus needed is 0.5. I got 0.73. So the answer is yes, this will work for doing the imaging from this machine. So that was the next question here. Then the next one is, the majority of you didn't get it, I don't know why, but I said that now if you cannot change anything, your machine is fixed, your wavelength is fixed without changing wavelength, without changing NA or anything, because depth of focus is there, your resolution is there, right? What can I do to improve resolution? And if you remember, we talked about you use the phase shifting mask. So at every alternate opening, you have a 180-degree phase shift. So what that does is that you don't have to draw that, but if you just said phase shifting mask, I would know what you're talking about. So instead of this case, when you have this, these things overlap, and you don't see the dark region, so it goes like this. So that's poor resolution. But if you phase shift the very next gap, it is 180 degrees. So at this point, you have the destructive interference. So you got a very nice contrast from here. Dark, this is one region. This is light. This is dark, and you don't have overlap here. So the answer was basically use a phase shifting mask, which shifts the phase by 180 degrees in the adjacent gap. That was the answer to that. But that was kind of only one point, but that was the question there. Second, last question, most of you got all right. I gave you D100 and D0 and asked you to calculate the gamma. So calculates its contrast value. D0 is given to you, the D100, so you calculate that. Then the next is they calculate the CMTF. Okay, so again, these two things are needed. Formula was there for you. You calculate the CMTF, which is 0.67. Then I said that what if I use this machine, that MTF is 0.5. So CMTF, if you remember, always has to be less than MTF, but in this case it is opposite. CMTF is greater than MTF, so the answer is you cannot use this for imaging because this does not meet the important criteria here. Then the last one was that which photoresist property would you improve to resolve the poor aerial image? So you didn't have to draw it, I showed you this was the idea, this was the aerial image, where the gray area was this much, right? But if you got D0 and D100, the gray area is reduced to this section only. So instead of this, so if I can increase the contrast by shrinking the gap, then my this image resolution will get better and better because the gray area will basically shrink and it will disappear if the two combine together, right? So basically the answer is just need to improve the contrast in order to get this result. And then I asked you to plot this for positive resist, which most of you got all right. So I think this is what we had, and it's not terribly